Okay, now with all the angles cranked out in degree form and radian form, how do we find the x-coordinate and y-coordinate of each of these angles? Now remember that the cosine of an angle is the x-coordinate of that angle, or more specifically speaking, the x-coordinate of this point here of that angle. And the sine function of that angle is the y-coordinate of that angle. So how do we determine that? Well, let's start out with the angle 30 degrees here. You have a 30-degree angle right here, and imagine you go from this point and you go straight down to this ray. Well, if you go straight out to this ray, it's going to form a right angle right here. So you're going to have a right triangle when you connect this point with this ray. So let's draw a separate picture of that. Let's just say it's going to look something like this. Okay, so this is the 30 degrees. By connecting that point of the 30-degree angle that we just talked about to the ray, or to the 0-degree ray, I should say, we're going to have the right angle 90. So by the triangle angle sum theorem, this is 90, this is 30, which will make it 120 when we add them together. Then the remaining angle is going to be 180 degrees total. Subtract 120, which is 60. So we have a 30, 60, 90 triangle right here. So let's just say I'm going to call this side x. And this side right here is y. But what about this side? What about hypotenuse? Well, the hypotenuse is going to be positive 1, okay? Because we're talking about a unit circle. And the unit circle is a type of circle whose radius is always 1. So the hypotenuse, which is technically the radius of the angle, is positive 1. But this is a 30, 60, 90 triangle. So by the 30, 60, 90 triangle theorem, we know that opposite to 30 degree is going to be just a variable itself. So maybe, not to cause any confusion here, we can let we can let y be equal to another variable by itself. So that other variable could be, let's just say w, okay? So opposite to 30 degrees is a variable by itself, so we call it w. Although we have y here, but let's redefine y to be w to be a little more specific. Now opposite to 60 degrees is the long leg, and this long leg is just the product of the short leg, which is w, multiplying by square root of 3. So that means what? That means x can be w times square root of 3. Now what about hypotenuse? Well, the hypotenuse is 1. By the 30, 60, 90 triangle property, we know that the hypotenuse is going to be equal to the short leg, which is w, multiplying by 2. So really, 1 right here is actually equal to 2 times w. But hey, guess what? 1 equals to 2 times w. Dividing both sides by 2, we got w equal to 1 over 2. Like that. So this right here equal to 1 over 2. So y is equal to 1 over 2. And x is going to be equal to 1 over 2 times square root of 3, which is equal to square root of 3 over 2. So the x-coordinate of the angle 30 degrees, or pi over 6, I should say, is square root of 3, my bad, square root of 3 over 2. And the y-coordinate of 30 degrees, or pi over 6, is 1/2. So really, this is the cosine of pi over 6. And this right here is the sine of pi over 6. And that is how we find the x and y coordinate of 30. Square root of 3 over 2, comma 1 over 2. Alright, now let's try to find the x and y coordinate of 45, which is pi over 4. So by connecting this point to the ray of 0 degree right here, we are going to form another right triangle. Something like this. this is the 45-degree angle that we are selecting to sketch this separate graph. By the triangle angle sum theorem, if this is 45, this is 90, whose sum is going to be 135, then 180 total minus 135 is going to give us another 45-degree angle, which is a remaining angle. So we have a 45, 45, 90. So by the 45, 45, 90 triangle property, we know opposite to both of the 45 degrees are the two legs of this right triangle. This leg is defined to be x, oops, my bad, and this leg is defined to be y, so x coordinate, y coordinate. And opposite to both of these 45 degrees is actually going to be a variable by itself, and they are going to be the same. So let's define x to be the variable w and y to be the variable w. By the same property, opposite to 90 degree is the hypotenuse with the value of 1 because it's a unit circle. This 1 is going to be equal to the variable of both of the legs. I mean the variables from both of the legs, which is w. But this w is going to multiply by square root of 2. But hey, guess what? We can solve for w by dividing both sides by square root of 2. So really, we're talking about 1 equal w times square root of 2. Divide both sides by square root of 2. We have w equal to 1 times square root of 2. By rationalizing the denominator, we are going to have square root of 2 over 2. Well, with w being equal to, square root of 2 over 2, we know right here y is going to be equal to square root of 2 over 2, and this is actually the sine of pi over 4. Sine function of pi over 4. That x is also going to be equal to square root of 2 over 2, and this is the cosine function of the angle pi over 4. So the x coordinate is square root of 2 over 2, and the y coordinate is square root of 2 over 2. Fill it in. Let's continue with this one then. Select 60, pi over 3. Plot this point here, connect this point to the ray of 0 degree. So we are going to have another right triangle. So this is 60 degree. 60 degrees by the triangle angle sum theorem. The remainder is going to be 30. So we have a 30, 60, 90 triangle property that we can use. So opposite to 30 by that property, let's define this to be the x and this to be the y. So by the 30, 60, 90 triangle property, opposite to 30 is going to be the short leg, which is predefined to be x. So by that property, opposite to 30 is actually going to be equal to just a variable by itself. So let's call it w again. By the same property, opposite to 60 is going to be the variable from the short leg w, but now it's going to multiply by square root of 3. Opposite to 90 degrees is a hypotenuse, which is predefined to be 1, because this is a unit circle. But now this 1 is going to be equal to the variable of the short leg w, but now it's more multiplying by 2. So solving for w, we know right away w is going to be equal to 1/2. So w equal to 1/2. If w equals to 1/2, we know the short leg is going to be equal to 1/2, and this is the x coordinate of pi over 3. Well, we know the y right here is going to be equal to 1/2 times square root of 3, which is equal to square root of 3 over 2. And this is the y coordinate of pi over 3. Put it in there. move on to this one. Well, this is the 90-degree angle. So we have a point here. But honestly, this point is just 1 unit away from the 0-degree gray right here. So really, and now of course it's on the y axis as well. So this point right here is going to have the coordinate of 0, positive 1. So cosine of 90, or pi over 2, I should say, cosine of pi over 2 is 0, and cosine of 90, or cosine of pi over 2 is positive 1. Now let's move on to this one. Well, for this one, you have to be a little careful. In order to find out the x and y coordinate of 120, we're still going to plot this point right here, and we connect it to this ray, this horizontal ray, but this horizontal ray is a straight line angle of 180, okay? So let's do that. So we're going to sketch like that. So by connecting this point to this ray of 180 degrees, we are going to form the right angle at the point of intersection. So it's right here, and the point is up here. But what about this angle? How many degrees is this angle right here? This is when we have to go back to the concept of reference angle. And again, reference angle is the difference between your standard angle, which is the angle that you go from 0 to like a certain to like any one of these segments, and that's going to be your standard angles. So really, from the 0 degrees up to here, you have 30 degrees. Well, this 30 degrees is your standard angle, and the same thing can be said for 45, 60, 120, 135, and so on all the way to here. The reference angle is just, again, the difference between that standard angle that you have and the straight line angle, depending on the quadrant. So if you're in quadrant 2 and 3, to find the reference angle, you have to take the straight line angle 180 and subtract your standard angle. Your standard angle can be this one, or this one. And in quadrant 3, it's this one, or this one, okay? Now, if you're in quadrant 1, and if you want to find the reference angle, all you have to do is that you take your standard angle, which is found by going from 0 to like a certain segment, any one of these segments, and subtract that with the horizontal angle of 0 degrees. Now, if you're in quadrant 4, instead of using 0, you only use 360 instead. So that's how you find the reference angle. Okay, so we have a standard angle of 120, and if we want to find the reference angle, all we have to do is that we take the straight line angle of 180 and subtract the standard angle 120. So 180 subtract 120, that's going to give us the reference angle right here of 60. Okay, well, if this is 90, this is 60, then by the triangle angle sum theorem, the remainder has to be 30. The remaining angle, I should say. And let's predefine this side to be x and this side to be y, standing for x and y coordinate. So how do we do this? Well, the same thing. By the 30, 60, 90 triangle property, opposite to 30 degree is a short leg divided by a variable. Let's call it w. Again, opposite to 60 by the same property is the long leg, defined to be the short leg variable w multiplying by square root of 3. Opposite to 90 degree is the hypotenuse, already predefined to be positive 1 because it's a unit circle. And the property defines the hypotenuse to be the short leg variable w multiplying by 2. So really right here, we have w equal to 1/2 if we were to divide both sides by 2 to solve for it. So w equal to 1/2, the short leg is going to be equal to 1/2, and this is going to be equal to the cosine of the standard angle, 120, which is 2 pi over 3. Sine of 2 pi over 3 right here, the y coordinate of 2 pi over 3 is going to be 1/2 multiplies square root of 3, which is square root of 3 over 2 equal to y, and this is sine of 2 pi over 3. let's see, right here. There we go. And that is how we find the x and y coordinate of this angle. Now you gotta be careful from here. We're in quadrant 2. So if you take a look at quadrant 2 consists of the negative part of the x-axis and the positive part of the y-axis. Well, if it consists of the negative part of the x-axis, the x-coordinate is going to have to be negative. So instead of positive 1/2, we're going to have negative 1/2. So put it in there. So that's negative 1/2 comma 2 pi over 3. Okay, now let's try to find the x and y coordinate of the standard angle 135 degrees. By plotting this point and connecting it to the straight line ray right here, we are going to have 90 degrees at the point of intersection. So sketching a separate picture is going to look something like this. Have the point right here. Sketching it down at that. So 90 degrees here. What are these two angles? Well, let's find this one first, because this angle right here is the reference angle, which is right here. So to find this reference angle, by its definition, to take the straight line angle that goes with the quadrant 2, 180, and subtract the standard angle that we are selecting, 135. 180 subtract 135 is going to give us a reference angle of 45, which is right here. 45, 90 degrees. We have to find this remaining angle. So by the triangle angle sum theorem, take the total degrees and subtract the two angles that we know. So 180 subtract 90 subtract 45 is going to give us another 45 degree. So we have a 45, 45, 90 triangle. So by the property of 45, 45, 90 triangle, opposite to both of the 45 degrees are the sides that are predefined to be x and y. And that property defines these two sides to be one same variable. So let's call that variable w again. And that property also defines the hypotenuse with the value of 1 to be that same variable w from both of the legs, but multiplying by square root of 2. So using this little equation and solving for w, we are going to have w equal to 1 over square root of 2, which is equal to square root of 2 over 2. Since w equal to this, we know x right here is going to be x equal to square root of 2 over 2. So this is the cosine of 3 pi over 4. Y right here is going to be equal to square root of 2 over 2 as well. And this is the sine of 3 pi over 4. So the x and y coordinate of 3 pi over 4 is, well, right now is square root of 2 over 2, comma square root of 2 over 2. However, because we are in quadrant 2, and quadrant 2 consists of the negative part of the x-axis and the positive part of the y-axis, we know that the x-coordinate of this angle, as well as the x-coordinate of this angle, and this angle as well, is going to be a negative number. So that's why the x-coordinate of 135 is negative square root of 2 over 2. Well, let's do the same thing for 150. Plot the point right here, connected to the straight line ray. It's going to give us the right angle at the point of intersection. Okay, now what is this angle? Well, this angle right here is the reference angle between the corresponding straight line angle of 180 and the standard angle. So the reference angle between a straight line angle 180 and a standard angle. It's just the difference between the two. So take 180, subtract 150, it's going to give us the reference angle of 30. So this is 30 degrees. 30, 90, the remaining angle can be found by using the triangle angle sum theorem. Take 180, subtract these two angles. So 180, subtract 90, subtract 30. It's going to give us 60 degrees left over. So by the 30, 60, 90 triangle property, opposites to 30 degrees, which is the sine predefined to be y, is just a variable by itself, so let's call it w. Opposites to 60 degrees, which is the sine predefined to be x, is actually the short leg variable w multiplied by square root of 3. Now the 30, 60, 90 triangle defined the hypotenuse, which has the value of positive 1, to be the short leg variable w multiplied by 2. So really using this equation solving for w, we have w equal to 1/2. With w equal to 1/2, we know x is going to be equal to 1/2 times square root of 3, which will give us square root of 3 over 2. And this is the cosine of 5 pi over 6. This right here is going to be 1/2 equal to y. And this is the sine of 5 pi over 6. Square root of 3 over 2, negative square root of 3 over 2. Because remember that quadrant 2 consists of the negative part of the x-axis and the positive part of the y-axis, comma, positive 1/2. And that's how we find the x and y coordinate of 150. Now, what about 180? Well, 180, we have a point right here. From the center to this point, that's technically the radius of the circle. So we know, and of course at this point is on the x-axis too, so we know for sure that the x coordinate is going to be -1 and the y coordinate is going to be 0. You guys can try to do the same thing for the remaining angles. In fact, this one right here is going to be positive 1, 0. So you guys can try to find the x and y coordinate of the remaining angles using the same method of plotting the points on each of these segments. Connect this point to a straight line or the horizontal ray that corresponds with the quadrant that your standard angle is in. Create a right triangle just like I did. Find the reference angle using its definition like you just saw. And then from there, just use either the 30, 60, 90 triangle property or the 45, 45, 90 triangle property to find the x and y coordinate of each of these angles. And over here, one more thing, we have a point here. Well, this point right here is going to have the x coordinate of 0 and the y coordinate of -1. All right. Now note that in quadrant 3 consists of the negative part of the x-axis and the negative part of the y-axis. So the x and y coordinate of all of the angles in quadrant 3 will both be negative. In quadrant 4 consists of the positive part of the x-axis and the negative part of the y-axis. So the x coordinates of all of these angles in quadrant 4 will be positive, and the y coordinate of all of these angles will be negative. So make sure you keep that in mind, okay?